In this video I am going to discuss about the questions from Clayden textbook from page number 640. So the first question is, how would you convert the bromoaldehyde 1 into compound 2 and compound 3? So let's look at the structures 2 and 3. In the case of compound 2, the bromo is intact with the product and the aldehyde is converted into the secondary alcohol. So how will you convert this aldehyde into a secondary alcohol? So when you react with the Grignard's reagent, aldehydes are converted into the secondary alcohol. Now let us look at the preparation of compound 3. So here the bromo is converted into the secondary alcohol and the aldehyde is intact in the case of the product. So how will you transform this bromo into the secondary alcohol? So here we convert this aldehyde into a suitable protecting group. So let us do protection of the aldehyde into an acetal. So we will react it with ethylene glycol in the presence of some acid. So we get the corresponding compound where the aldehyde is protected, and this bromo compound is converted into the Grignard's reagent by reacting it with the metal magnesium. This is the Grignard's reagent, and this Grignard's reagent on reaction with the aldehyde, so we get the secondary alcohol. And this protected aldehyde on deprotection with H plus, we get the product 3. The next question is, explain the chemoselectivity of these reactions and what is the role of trimethyl silyl cyanide. So in this reaction there are two carbonyl groups in the starting material, this one and this one. So in the first step the starting material reacts with the trimethyl silyl cyanide and we get the intermediate. So this is the cyanohydrin, and this cyanohydrin on reaction with methyl lithium, this carbonyl group is converted into a alcohol. So here there are two carbonyls and this carbonyl is the less reactive. So how do we know that this carbonyl is less reactive compared to this one? So here this methoxy group, we have lone pair of electrons on the oxygen, and this moves over here and this bond pushes on here, and this carbonyl is in conjugation with the methoxy group. We have double bond OMe, a positive charge on the oxygen, and here. So both these structures are in conjugation, and therefore this ketone is less reactive because it is more stable. So here in the first step, this the more reactive carbonyl is protected with the TMS cyanide, and we get the cyanohydrin. So that is and in the next step, the methyl lithium is added, and this methyl lithium is added, and this ketone is converted into the alcohol. And in the final step, this F minus, which is used for the D protection, will come and attack here, and this will come here, and the cyano will go out. So therefore we get the final compound. Third question is, how would you convert this lactone selectively either into the hydroxy acid, this one is the hydroxy acid, and the unfunctionalized acid. So if you look at the reaction, this conversion into a hydroxy acid is a simple hydrolysis reaction. If you take the aqueous sodium hydroxide, we will get this hydroxy acid. So reaction of this lactone with aqueous sodium hydroxide will give us the hydroxy acid. And in the case of the conversion to unfunctionalized acid, so we have to attack at the secondary benzylic position, that is reaction with hydrogen and palladium and charcoal will yield this product. The next question is, predict the products of Birch reduction of these aromatic compounds. Here compound 1 and compound 2. In both these compounds we have the electron donating substance, that is OMe. So in each case the electron donating group will be on the alkene, and electron withdrawing group will be away from the alkene. So this is an electron donating group, and in the case of compound 1 we have the anion in the ortho and meta position, since electron donating group stabilizes the ortho and meta position. So this is the product. And in the case of compound 2, again the electron donating group stabilizes the ortho and meta electron density. This one is the meta and the ortho position. So this is the product. So the next question is, how would you carry out these reactions, and in some cases more than one step may be needed. So the starting material has two functional groups. So one is the hydroxy and the other is an ester. So in the first step we are converting this aromatic ring into the saturated hydrocarbon, that is cyclohexane. So this is a hydrogenation reaction, and the reaction can be done with ranny nickel in presence of hydrogen, or we can also use platinum oxide. And in the second step, where this hydroxy group is oxidized to a ketone. So for this, this is a straightforward oxidation reaction where the chromium oxidants can be used, either chromium trioxide or chromic acid or any other oxidizing agents can be used. And in the next step, where the uh, ester is reduced to the alcohol. So reduction of esters to the alcohols, they need a very strong reducing agent. So here lithium aluminum hydride is employed in this reaction. So this ketone has to be protected. Ketone is to be protected. So here the protection can be done with ethylene glycol, that is the formation of acetal. So next is we reduce it with lithium aluminum hydride and ether as the solvent. Then we get the alcohol. And in the next step, we will hydrolyze it with an acid to give the product. So here in this reaction, since ketone will also be reduced, we have to protect it with the acetal and then reduce it with lithium aluminum hydride and then do the deprotection with acid to give the product. So the next reaction is how would you convert this nitro compound into the products shown below. This is the A and this is B. So let us look at the preparation of A from the starting material, that is the nitro compound. So the first step is we have to reduce the nitro compound, that is with palladium on charcoal. So that nitro compound is reduced to the amine. So in the second step, we are doing this cyclization reaction with the ketone and we get the cyclized compound. And in the final step, we have to reduce it again with palladium on charcoal to give back the compound A.